Hey, this is Don from Padlock Technologies again, here with another theory video. This time we're going to talk about how to stop DDoS attacks or denial of service attacks, the dynamic denial of service attacks using BGP. Now, BGP is a very well-known protocol. It can handle a lot of NLRI or network layer reachability information, and there's so many different AFIs, sub-AFIs, or SAFIs that are used to carry that information. And you can also now use BGP to stop those DDoS attacks. Now, this is not something that you're going to do by yourself. You will need to partner with your service provider in order to get this coordinated. But it will stop it in its tracks. There's two ways you can do it. You can completely stop the traffic, or you can redirect the traffic to a cleaning center, and then they will send you the clean traffic after it goes through its cleaning center. So this kind of spawned off of a technology or a technique called remote trigger backhauling. What I'm going to do is going to talk about that briefly, and then I'm going to tell you about BGP flow spec. So let's go to the blackboard here. Let's put my title here, BGP flow spec. All right. Now there is a VPN v4, VPN v6, and regular GRT of this, but we're just going to talk about just the theory as a whole. We're going to talk about global routing table on this point. But first, let's talk about remote trigger black holing. So the whole purpose of remote trigger black holing, this was pre BGP flow spec. It is an option, but there are some cons in it that kind of doesn't make any sense for you to do remote trigger black holing. You might as well just go to BGP flow spec. So what does that look like? So let's say you had a couple PEs here. Those 3 PEs. And then we got your network, service provider, SPNet. And then you have your CE here, directly connected. Now this is a peering VPN, so this is not a layer 2 VPN here. And then you got, another network, your network there, and then ultimately you got the host. And let's say this is a web server. All right. So what ends up happening with remote trigger black holing is if this PE was connected to another network, and then this was down here somewhere, and let's just say attacker decided to do a DDoS attack. So they decided to do some kind of TCP SYN flood or whatever. And now they're like blitzing the mess out of the web server host, and now your web server is just unavailable. So what you would do is you would call up your service provider, or you would set this up with your service provider, and the service provider would say, send me the community value, BGP community of, let's pick a community value, let's say 4444. So the PE now is going to be looking for that. And what happens is when you send that to the PE says, if I'm going to match the community value of 4444, and then I'm going to set the IP next hop to some address. Now that address on PE is going to be a static route that goes to null 0. So now that route is going to say, all right, well, to get to this next hop, get to the web host, go to this next hop. That next hop is actually a null route, and it's going to drop the traffic. Basically, that's the whole point of remote trigger black holing. I'm going to black hole the traffic, and I was remotely triggered by the CE by this community value that I picked up on. Problem with this is you have to do this on every PE in the network. That is an administrative nightmare depending on how many PEs you actually have. So you don't really want to do this. The other thing is this /32 that you're sending them with that community value on there, you're basically blocking all the traffic, no matter what the traffic is. Again, if this was something I'm just going to send a bunch of SYN packets, doesn't matter. You're just going to block traffic entirely for that /32, and you're going to be blocking legitimate traffic. Because of those cons, you want to go to BGP flow spec. So this is where BGP flow spec came from. So let me show you what BGP flow spec actually does. So we're going to have the same diagram here. PE, 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 service provider network in between, SPNet, CE here, host. Let me just say web server. Same concept. Difference is there is a PE in this network that is a management server. That's what it is. It's a management server. And all of these PEs, let me use white. All of these PEs here are going to go to this management server, and they're going to have an adjacency for the AFI, sub AFI is going to be flow spec, or in this case, IPv4 sub flow spec. All right. Now, what's the difference? So let's say this PE down here is connected to a different network. And then you have whatever router over here, PE over here. And then we have their attacker machine. All right. Now let's say they were doing the same attack as in remote trigger black holing. So let's say this time it was a ping of death attack. So they're just flooding this thing with ping of death. All right. Flooding it with ping of death. What you would do is you would call up the service provider and say, hey, we see this DDoS attack, looks like it's a ping of death, pinging our web server, and then, you know, our web server is being bogged down because of this. What the management server will do is it will create there's two things. There's a class map called traffic, and then there's a policy map called PBR. Those are the two components. But what the class map is going to do is they will go, all right, you have a net problem, so we're going to say class map. It's going to match destination, IPv4 address XXXX, all right? Then it's also going to match, you can match protocol, ICMP, you can match a bunch of stuff. And then when you had a policy map, so you have policy map, whatever the name is, and then you'd match the class map, or you'd have, you know, class, whatever the class map is. And then you would say you can either drop it or redirect it somewhere else. But in this case, we're just going to drop it for now. So what that's going to do is that's going to get triggered on each of these PEs in the network because I pushed it from here. And then I'm going to say, now what's going to happen with the attacker traffic, ping is going to be dropped. Let's say I picked a drop action. So ping is going to be a drop action. And everywhere in my network that is doing flow spec is going to drop it based on the criteria in my match value. So, hey, it's going to this web server and it matches ICMP. I'm going to drop that immediately. So that immediately kills all ping of death. Same thing with TCP SYN floods, all of that good stuff. You match the destination because you're not really going to know the source because of dynamic DDoS attacks. You don't know where it's coming from, right? It's a bunch of people flooding it at one time. So there's no point of matching on the source. You just match on the destination. Here's the destination. Now, normally this is going to be a public IP address that you got out to the world. You're not going to do it on the private IP addresses because those are not routable. So you'll have a public IP address for the web server out into the world. And then you'll say, okay, we're going to match the destination of this public IP address, which nats to a private IP address, but we're going to match ICMP traffic, and then we're going to drop it. why is this better than remote trigger black holing? Well, it's better because I don't have to create a static route, null route on each PE. Only thing I have to do is put whatever new PEs in there. I just have to have an adjacency for the Address Family IPv4 flow spec. If it was VPN v4, you would do the same thing. You just need to do it under VPN v4's flow spec and not IPv4 flow spec or IPv6 flow spec. And this is domain wide, because in remote trigger black holing, if you misconfigure or you miss that configuration with the community value, that, well, that's a hole in the whole situation, right? This avoids that because it's going to be centralized policy management by the policy server up here. This is almost 99.9% effective, right, to blocking DDoS attacks. Now, there is another way, and they do have this other thing here where I said redirecting to a cleaning center, where your CE, let's say you had they had another PE over here, and then this PE was at the cleaning center. So clean center. Now here you would have a GRE tunnel. To that other PE in the cleaning center. And now if you pick the redirect, what these PEs will do is they would send the traffic. I used that already. They would send the traffic to the cleaning center. The cleaning center would clean the traffic and then send that clean traffic down to the CE. So they would remove all the crap that the attackers are doing, and then send it down to you, and you'd have technically clean traffic. So that is BGP flow spec in a nutshell. That is exactly how you would, stop DDoS attacks in their track, by partnering with your service provider and getting them to implement this feature for you. Now, it's not automatic. You do have to call them up and say that you're having a DDoS attack. But once you do that, they put the policy in motion, and then bam, DDoS attack pretty much gets stopped. I hope this video was informative. Keep sending me more questions. I do all kind of technologies, and I like talking about this. So the more questions that you send me, the more answers I can give you. Again, this is Don from Padlock Technologies. Thank you. Have a nice day.